That's what I'm going to do. Hey everybody, I'm recording, and I'll be sharing the screen in a second. The thing I wanted to go over with, and I guess I'll just have to send an email out to everybody to make sure everybody gets it, is on the course syllabus-y stuff, not that. Oh, wait a minute. Okay, let me go here. Courses. No, CMC. EU / shoot. Oh, I know what I need to do. This, okay. Sorry, I have like little handy shortcutsy things. There we go. Yeah. Okay, so down here, okay, today we're going to do live streaming. Okay, that'll be fun. Next week we have a couple of really good guests, including our own Ben Holtzman, who's right there in the Zoom chat. There he is. Hey, Ben. Okay. Then after this, notice that I have this project reports here. Okay. The point of that is not to have like a project report, really. We're going to take some time and discuss like what you might have as ideas for projects that you want to do, and talk about feasibility and, just kind of bounce things around. So over spring break, think about what you might want to do for this class, by that time, you will have seen a lot of the stuff that we wanted to cover in terms of how to sonify, how to graph, how to plot, things like that. So you can start thinking about, what is it you'd like to do, yeah, so we'll spend a fair amount of class talking about that. And then after that, we have a series of special guests coming in, doing different things, especially talking about using of AI for feature extraction. And the cool thing is that most of them have written like objects that work inside MaxMSP. So we're not going to be doing any big coding with that. They're just kind of turnkey things that just work. And it'll be interesting to see what they have to say. So these are the guys that actually developed the code. So yeah, they're kind of well known. It'll be fun to have them around. Okay, but tonight, yes, we're going to be doing live streams. I have to tell you, Ben, this class has been really hard for me because I had to develop everything from scratch. And the miracle, the point where I realized that, okay, I think the rest of the year is going to go okay, was when I figured out how to connect to a weather data station on Whidbey Island. And we're going to do that. We're going to do that tonight. All right.
Right.
But the first thing we're going to do is we're going to talk about live streams from devices, because that's a type of data sonification you have to do. And I brought along the Brainwave sensor. Oh, hey, C1, come on in. Oh, that's Hannah. Oh, yeah. Oh, no problem. Well, you have to leave then. I'm kidding. I'm just getting going with it. So yeah. Like I said, you picked a good class to come to. All right, and what I want to do is show you. We're going to kind of take it very simple at first, and then I'll show you a finished application, and we'll have a little sort of thing going on. All right, but I want to show you how to get this thing going. All right. And it's a little tricky. This is a product called the Muse Headset, and we use it here at the CMC because they're $200 each, as opposed to Vinay, who's over there, who works in Nima Mesgarani's lab, and they're like $50K each or something, right? Yeah, they're not cheap. But it does what we want it to do. It generates data, and we'll look at how we can intercept that data stream and turn it into sound. And I'm also going to show you a fairly extensive sort of application that not only just sets it up with sound, but also sonifies it using logic instruments and all kinds of stuff like that. Okay. But it's a little tricky. The original model of this would connect by Bluetooth directly to your computer. All right. That no longer works. What they have you do is you have to connect through your iPhone. And the reason I'm showing you this is kind of becoming the standard paradigm, because after me, Nicola is going to show some stuff, and it also connects through his iPhone. So just kind of stay tuned for that. Let me, I guess, at first I don't need to share my screen because I need to show you, well, I do need to share my screen. Hang on a second, guys. I'm going to share my screen. All right, share screen. Yeah, we want to share sound. I want to make it stereo, okay? Okay, so you guys can see my screen now? Yeah, you can see all my like windows and all this stuff. Yeah, I don't think, I'll do a little bit of typing in of stuff tonight. And you can also see my window where I am waving my hand, right? Okay, because I'm going to be showing you stuff on here. And Nicola's like cool because he's younger and he understands technology now. And he knows how to share his iPhone screen. Yeah. Yeah, but I'm not even going to try. I'm just going to hold it up there. Okay. So what you have to do to get the Muse to talk is, first of all, it's using OSC and that UDP send and receive stuff that we talked about at the very beginning of the class, to get stuff to go from max MSP into processing. However, as I mentioned then, it's an internet protocol, and you can actually go between devices. And we're going to use the magic of the World Wide Web and wireless connections to do that. But the thing you're going to need to get is you're going to need to get the IP address of your computer. So you see my system preferences here. I'm going to go to the network, and you go to advanced. And then you go to TCP/IP, Transport Control Protocol, Internet Protocol. This is the stuff that UDP runs on. And that's the one we want right there, your IPv4 address, okay? So I'm simply going to copy that out. Well, actually, I can just keep it there. And what I'm going to do now is start up my iPhone, type in my secret password, and the thing you're going to look for, or you're going to have to download, and I'll put a link in on the web page, is this thing over here called the Mind Monitor. Okay, you see that guy that's got the yellow around him? Okay, all right, I'm going to start that up, all right? And the first thing I see is it says connection help and connection info. It's waiting to be connected to your Muse headset. And I do that by just turning it on, and the on switch is right there. So I'm going to turn it on, hold it down, and let's see, turn it on. I'm going to hold it down. Oh Lord, turn it on. Ah, there we go. Yeah, see, it's got a light that turns on. Okay, so once this starts happening, okay, then this should connect automatically to the iPhone. Okay, come on, connect. Here we go. Here we go. Oh gosh, I forgot. I turned Bluetooth on this off. Hold on a minute. I was doing some stuff earlier and I had to turn my Bluetooth off. Okay, so yeah, this is a good lesson. Make sure your Bluetooth is turned on. Okay, yeah, you couldn't see that at all, but I'm turning it on now. Bluetooth. Now we're going to go back to the Mind Monitor. Where did it go? Yeah. And now it should connect. You might have to, yeah, there, it's connected. See, it's doing stuff. It's got like a graph and it's got a whole bunch of numbers and things, okay? That means it's now receiving data from the headset. Now, normally at this time, I would do like a fun thing and say, I need a volunteer from the studio audience to use this, but we're still kind of in COVID, so I'm gonna use it. This is mine, okay? So I'm just gonna put it on. And the way this works is it has these sensors here, okay? And this one is the ground, and then it has 4 other sensors that it will generate data from, okay? And you put that like this, and it just hits right on your head, Dave Seltzer likes to put it back on his occipital lobe, okay? And now you can see that 2 of the sensors are working. The outer 2 don't for some reason, but that's okay. And, if I clench my teeth, watch where the blue line is. Arrgh! See? Here it comes again. Arrgh! Yeah. All right. So we're happy. How do we get the data from the phone to, this is what you need to know, Hannah, okay? What you do is you go down here, and there's this little circle-y thing that looks like it's broadcasting. I'm going to hit that, and it says it's streaming somewhere. That's not what I want to do first, okay? First of all, I have to go to the gear, okay? And under the gear, there's a thing that says OSC, oops, darn it. It says OSC stream target IP, okay? what I'm going to do is put in that number 129.236.178.104, okay? Now, before I do that, though, I'm going to start up my receiver patch here, okay, so that we can see what happens, okay? And what I have here is the basic Muse Max Pat, all right? I'm starting this up. And the thing that you'll also see if you look down those sort of things on the settings is that this is going to stream. Remember, we have to set a port number on these UDP things, okay? And Muse uses port number 5001, okay? So I've got this object up, UDP receive, all right? And then there's a bunch of stuff that you can get from it, and somewhere there's documentation where you can actually get alpha wave patterns from it. I don't think their DSP is all that good. But you want to get every sort of message that's tagged with Muse. And then I'm going to look underneath that for messages that are tagged with EEG, because I just want the raw EEG data out of this, okay? And then those are the 4 sensors, all right? So what EEG stand for? Electroencephalograph. Okay, that's basically just measuring the electricity in your brain, okay, from all the neurons that are doing electrical things. He's the expert. This guy, like, I'm not kidding. That's what he's getting his PhD in, you know. So this is kind of goofy for him, but
using it is not.
It's fun.
This is the fun part.
Yeah, it's fun. Yeah. He's here for fun. Vinay's taken several of our classes, and he's been doing some amazing stuff. All right. So when I get this connected properly, so now I'm going to type in my my IP address, okay, and I go down here, and what was that number again? Let me look at it here. Network. Okay, 129.236.178.104. 178.104. Okay, 129.236.178.104. See, I typed it in right there somewhere. Okay, now I go back to that place, and that weird little broadcasty thing, when I hit it, it will say streaming to 192.168. And if I go over here to my Muse stuff, it's not working at all, is it? Oh, I didn't set it. Huh. This isn't good. It should be like streaming stuff. Maybe I typed the thing wrong. Streaming to 129.236. Go back there and look at this. 129.236.178.104. Okay. All right. Okay, I think I know what's wrong. Okay, I'm going to have to do one more thing. And this is something that I didn't anticipate, but we're going to see if we can get it to happen. Okay. Here we go. Yes. I need to connect to the Wi-Fi on my phone. It was automatically connected at home. Okay. So I'm going to say here, connect, and I'm going to go to Columbia University, because that's what this is connected to, I believe. Yes. So it was trying to go from like the 5G phone thing to this, and it's just not going to happen. So I now connect to Columbia University. It's happy. Now let me go back to my Mind monitor. And we're going to hit this streaming thing. And it's still not working.
Can we use these for our project?
Yes, you can. We have some here at the CMC, yeah. But why is it not working? Okay, guys, this is really not happy, because it should just like start numbering, and this is going to like really change the rest of my lecture.
Just reconnect.
I wonder. Okay, let me just check this. No, I'm getting, the packets are flowing. Let me restart the application now that I've got the Wi-Fi going. And maybe something weird like that happened. Okay. Sorry about this. I told Hannah this is going to be so great. It works so easily. It's wonderful.
At home, I also tried the exact same thing, except that I don't have that Max script.
Yeah.
I use something I find on GitHub. It's a Python script.
Ah, right.
And I could also receive, but it just gives me long numbers. I don't know how to deal with.
Okay, this should work. This should work. You might have been picking up the OSC weirdness of it. You know, that's the only thing I can think of. Okay, so this is connected to Columbia University. Yes. Okay, now let's go back here. I'm going to turn this guy off for a minute. Reconnect it. Let's go to our Mind Monitor. Sorry about this, everybody. This is supposed to be so easy. Now I'm going to reconnect. Okay, you'll see when it connects. Yeah, see, now it's connected. Okay, let's go to our settings. 192.236.178.194. All right, 192.236.178. Oh, there's the problem. My eyes are terrible. Notice that this says 104. I typed in 194. That's a problem. This is not good. Oh dear. And now my phone is falling down. Oh golly. Oh, now it went back to settings. Oh, now go to Mind Monitor. Let's go back. Yeah, this is wrong. I guess it doesn't really matter. Where am I? Hold on. Okay, hold on. For some reason, I'm sending a message. Delete draft. Okay. Ah, here we go. Okay, so it's sending the data. You know, I'm now like, okay, now let's go to here. Let's go to our settings. And let's type in the right number. Okay, 0.104, correct? See, it's these stupid tiny little keyboards. Whoever designed these, they're wrong. Okay. Okay, so let's hit that. And now, let's try turning it on. Yes, yay! There they are, okay, yay. Oh, Ben, you've got your head in your hands. Sorry about that. It was supposed to be so exciting. Okay, anyway, there they are. Those are my brainwave numbers coming through loud and clear, okay? All right, now, the problem is we can't really tell a whole lot from those numbers. Those are the numbers you should be seeing, by the way, okay? I'm suspecting maybe it was an integer versus floating point or something. I don't know. Okay, well, that's floating point too, so weird. Okay, I'm wondering if it might be picking up on the /muse or the /eeg ahead of it. You know, I don't know. Anyhow. There's 4 different sensors, remember? So each one is one of the sensors. Now notice that the on this, the outer 2 sensors are bogus. I don't know why they're not working, but you can see down here, it shows you the middle sensor is the ground, and then the blue one and the purple one, those are the ones that are working, and the reddish one on the far sort of corner, that kind of is working, okay? We're going to talk about how we deal with that, okay? But the next thing I want to show you is how we can like plot that out or look at it in a little bit, look at it a little bit more elegantly, all right? So I'm going to start up a different patch here. So we don't need this anymore, yay. Okay, we're going to look at this. And I'm using a thing here that's interesting. This is actually a Max object called multi-slider, okay? And what it does is it takes data, and I'm mapping the data between 500 and 2000, which I've gotten just by kind of looking at those. And I'm mapping it to between 1 and 500. Each one of these sort of graphy points is actually a little slider on Max MSP. And you can actually edit this if you want to. But it's just a very simple way of displaying stuff. And again, I can show you it's working. I can clench my teeth. Arrgh. See that? Arrgh. Arrgh. Yeah, when we do concerts sometimes, we told the musicians, if you're not getting any action out of it, if you clench your teeth, you'll get a spike. So by the end of like a string quartet, like the entire quartet is going, arr, 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 like that, okay? So this is pretty cool. Notice I'm using only tapping one sensor, however, and it's also very kind of spiky and stuff. Now, the next thing I want to show you is Yeah, there's other problems with this that you don't recognize. Because this is like real-time data, I just assumed that the range is going to be 500 to 2000. Now, that will change over time. And what I have to show you next is a way of kind of keeping up with those changes, okay? And that's this thing, okay? What I've done here, first of all, is I've combined all of the numbers into one number just by summing them together. Now, notice there's this thing that says normalize. When I hit this, it's going to look for the minimum and the maximum until I hit the bang again, all right? So here I go, I hit this. Oh, look, it's not connected, is it? That's a problem. I need to take this and put it up there, all right? And I need to take this and put it there. I need to take this and put it there. Now, right now, all of the data points are higher than 500 because they're not being mapped properly, okay? What I'm going to do is hit this bang. And what it's done is it's kept track of the range of this data. And if I hit it again, if the data has moved around, then it will kind of rebase it so it will fit between 0 and 500. That's what this is, the small number, that's the 500. Now it's 2127. This is the large number, which is now 4487. And if I hit this, it'll do it automatically every 10 seconds. So when we're using this for performance, we just turn that on so that we're always guaranteed that we're going to get the data points within the middle part of what we're doing here, okay? Now, notice, however, still it's very, very spiky, okay? That's because your brain waves are very noisy, you know? A lot of times when we do this, Dave and I do this as kind of a didactical kind, autodidactical kind, or didactical, whatever, pedagogical, educational, you know, we talk about it. And we're seeing the overall output of your brain, you know, and it's just like kind of crazy. We get questions like, well, if you imagine Mozart, will it play Mozart? No, it won't play Mozart. It'll play, you know, because that's just how it is. But there is a way that you can kind of get a handle on this a little bit. And that's the last thing I'm going to show you. And then I'm going to show you the finished app, okay? So, I should have saved it.
Sorry, can I ask?
Sure.
What does the value stand for?
It's a multiplication up of the millivolts, right? You guys are doing with millivolts, right?
Maybe microvolts.
Microvolts, yeah. So they're very tiny voltages, and what they do is they multiply it up to like some arbitrary range that you see. Okay.
I thought it was frequency.
No. That's actually the electrical voltage coming from your brain.
So is it the amplitude of electrical things going on?
Yeah. Yeah. But again, it's like the sum total of all of your neurons, all of your billions of neurons that are putting out these microvolts that create this that we can actually detect. Okay. And again, you're looking at sum total, so you're not going to get any kind of sense of, you know, when you're dealing with the 8-channel stuff, you can at least get a sense that, oh, that's from the occipital lobe or something like that. You know.
The front or the back?
Yeah. If you guys are interested in this, Dave Salter actually teaches a class here in the fall called Music Minded Brain. And this is a really, it's all about.
Would recommend. Great.
What's that? Yes. Yeah. Vinay took it. It's really, really great class. Dave is a really well-known like neuroscientist, you know. Yeah, he's a good guy. Okay, so here we are. Okay, let me normalize it now. Okay, and notice that I have this output connected to this thing that says J0.smooth. Okay, and notice now it's really smooth. Okay, this is the smoothing coefficient, and if I turn it up to like 0.9, it won't be smooth. It'll be spiky. But what I'm doing is I'm essentially applying a low-pass filter to this. So if I bring it back down, you know, then I can get it sort of like being kind of more reasonable in terms of like how it's moving, you know. And that's what we use when we do our performances, you know. We can, that was me moving my mask around. Yeah, and this is me waggling my eyebrows. You have to bear in mind that the reason that the clenching of your teeth and the waggling eyebrows works is that your muscles also use electricity. Neurons actually trigger them with electrical outputs. And they're like an order of magnitude more. So, you know, when I do this, it's a lot. There. Oh, come on. Oh. little network bubble there, okay? Yeah, all right. So that's essentially how it works. You know, this should work for you, Hannah. I mean,
On my monitor, we can separate brainwave by frequencies, that's the theta,
you can,
whatever, alpha.
right.
Can we do that on Macs as well?
Well, yes, you can. See, what they're doing is they're all tagged with OSC tags. /Muse is the one that gives you all the data. I'm intercepting /EEG here, but you can also intercept /alpha and /gamma. Somewhere in their documentation, they have all the different things, all the data you can get from it. Now, I don't know how good it is. You know, alpha waves, you know, I don't know how well it actually is at detecting the alpha waves, you know, given the mess of what we're seeing here, you know. But supposedly it'll work, you know, and you can try it out, you know. But yeah, there's quite a bit of information you can get from this thing, okay? All right, well, let me now shut this down, and I want to show you a finished application I did, and then how are we doing on time? We're doing great on time, okay? And then I'm going to let Nicola take over and show you his magical iWatch, okay? And for this one, I'm going to go over to Sound and Neurosoldier. Okay, and I'm going to go down to Margaret. We did this one with Margaret Lancaster, the famous flutist in town. And what I'm going to do here is basically start up Logic, okay? Because that's going to be the thing that I'm going to use to create the sounds for this. I'm not going to use RTC mix because Logic has a lot more instruments that are a lot cooler, okay? So it's going to load up this Logic project, and I'm not going to record anything with it. I'm just going to use it to play back different instruments that it has, okay? So I'm going to move that over here onto this screen, okay? And then I'm going to start up the Max patch that shows you the interface that I use when we're performing with, say, Margaret Lancaster, the flutist. Okay, and there, you know, you can see my signals coming out, jiggling my brains, you know, and here's my normalizing. I'll turn that on, okay? And yeah, now let me show you how this works. Notice that there's all these kind of weird sliders and things like that, and then like these bizarre, I'll get this out of here, like keyboards around. Well, this is using a thing in Max called presentation mode. And if I unclick this, you'll actually see the Max patch, okay? There's all this stuff. This is where the Muse things, like here's an example, like here's the alpha session. That's the alpha thing. Like you go to /elements and you can get, I think, delta and gamma too, I believe, you know, and some other things like that, all right? There's something else that I want to show you too, that's down here. Notice I have these things that say call Mage, call Mine, call Chrome. These are essentially the pitches for the major scale, minor scale, and things like that. Notice that I can select what scale I'm going to choose from. Basically, it's just selecting one of those things, all right? And what happens is it takes this signal and basically sends this signal to each. Notice that this says P flutes and P long and P piccolo. These are all set to different MIDI channels that go to Logic, okay? And what happens is that the signal comes in here, then it gets scaled to some reasonable MIDI note value, okay? And then I put the speed limit on it because if I just sent the raw data in, it would be generating MIDI notes every time it generated a new data value. Like that, okay? So I'm cutting that down, and I'm going to do something else with it too. But finally, down here, this is how I can send a MIDI note out to Logic. Each one of these different things then goes to a different channel. That's going to channel 1. If I go down here and look at the piccolo, that's going to channel 3, you know, all this stuff like that. Now, these weird sliders and things like that, again, I'm not going to go through the internals of the patch. I'll put the patch online and you guys can download it if you want, but this is pretty insane match patch, you know, because I'm not very good at it, okay? What they do is I can set how long the notes are that are being generated. First of all, I can choose like my basic pitch. We'll play it in C. And I can actually set these to play like different pitches as their base. You know, like I'll just leave this one at C. But this will determine the duration of the notes. And this low interval and high interval This basically sets how much time is going to be between each of the notes that it generates, okay? And it's going to choose it randomly between those two intervals, okay? So if I turn this on, okay, I'll go here, and I should be hearing sound. I think I need to do this though. Go to audio. Let's go to general. Actually, there's, audio. Where does it say? Yeah.
Yes, exactly.
Yeah, where is it? Oh, system setting. Oh, sorry, I couldn't even see it. I'm like looking at it. Okay, I need to go to Zoom audio device. Okay. All right, supply our changes. Okay. Now let's go back here. Okay. And here we go. Okay. Can you guys hear that? So basically, I can set my node here very short. I can set a very tight interval here. Okay, then I'll add some gamelan. What's the okay, let me add some nice piano. Okay. Okay. And apparently it's not very happy with this. Okay, I'm going to turn it off. You know what? I can test this on Zoom, and it's like obvious. Okay, but essentially that's how it works. Okay, so I'm taking the brainwaves. It's just a noisy signal. I just do a little bit of massaging of the signal here in terms of setting how the notes are being scheduled, what the duration is, what their general pitch set is, you know, and the rest is all kind of fun with this. And we actually have a CD out, and I'll put a link to the CD, the Bandcamp thing, so you can listen. We did sessions with Margaret Lancaster playing flute. Dan Truman brought his Hardanger fiddle up from Princeton and played that. Gosh, I forgot the percussionist's name. He's famous. He played with Miles, not Miles Davis, played with James Brown. Anyhow. And, Terry Fender played mandolin. Yeah, so yeah, fun stuff. But that's all for now.
To clarify something
Okay.
about this, the duration and then the interval, below the high interval, those are always manually set. You never had that be controlled by anything else?
No. Yeah, basically I'm deriving the pitches from here, but the pitches are being mapped depending on what scale I've set, okay? Right. And then all this stuff is just having to do with the scheduling of the pitches and the notes and things like that. Okay.
The only thing the neural data is used for is the pitch itself. Right. Yeah.
Exactly.
And then that's done in Logic. That's an important.
Well, Logic is this thing over here. Okay. Basically, Logic is a big recording thing, but what I did was I set it up with 11 different channels, MIDI channels. And the thing Logic comes with is a whole set of really good instruments, you know, that are already kind of pre-made like that. So basically, they're listening as if I were going to record, but I never actually record with it. Yeah.
So the other interface, what is that?
Okay, this is the thing that I use when I perform, and this sets the parameters in real time that are then being sent to Logic for the sound.
How is this made?
That was Max MSP. Yeah, they're insane. Yeah. Oh yeah, you had a question too.
Yeah. Okay, so what do you think would be the best way to program this to actually understand anything about the signals? Or are they too noisy for really?
I'll be honest with you, they're really noisy. Yeah. The best way to do something like that would be to talk to Nima, who is his major professor. Yeah, Vinay. When I talk about this Nima character, Nima is just doing amazing things, like reproducing from this signal that you see the sentence that you're hearing. I mean, it's like magic to me, you know. And he's won like a NSF Young Investigator of the Year award and things like that, you know. And so yeah, and they're using very high-end EEGs that allow you to do, you know, very fancy things with it and stuff like that. So,
well, that reconstruction stuff we only did with invasive. It's like electrodes in the brain, not on the surface.
I thought you could do it from the surface now. Yeah.
It's very, very rough.
Oh.
We can't tell what words, but we can tell speech or not speech or things like that.
Right. Okay. Okay.
I want a permanent one.
What's that?
I want a permanent in
I
there.
know, I'm like, oh, it's like, that would be so sick.
Oh, you young students.
So with invasive methods, you are able to really get the test.
Yeah.
Yeah.
It's uncanny.
If
It's like
somebody-
science fiction. Yeah.
If somebody has these electrodes in their brain, and then a person says to them, 1, 2, 3, 4, 5, you can, from the brain recordings, you can reconstruct
Yeah.
1, 2, 3,
From
4, 5.
those,
Yeah.
from that, basically, you can get.
That's incredible.
It's totally
And
incredible.
if the person like doesn't speak the language that they're hearing, does it come out
That's very
garbled?
good.
Oh, that's a really good question.
just
We don't
hear-
know.
This is cutting edge research. I think you just gave,
I think
maybe
research
he's got a
idea,
PhD talking about.
Yeah, exactly. New thesis.
Yeah, Hannah, you had a question?
I know that I have used Muse before, and I know that when you pick up the low signal, it's kind of the blue side because your
Yeah.
motor signal is very nice.
Yeah.
And I'm just thinking musicians, like whatever artists, anytime artists they want some extent of control over the effects.
Yeah,
But it's a very hard thing to control the brainwave.
you cannot. You
And
simply
since you're
cannot.
mapping, since that you're mapping the intensity of the electricity rather than the frequency, because the frequency is polarized.
That's true.
Whether you're in a resting state, in what exciting state, I always suggest that the frequency will be more useful.
Yeah.
when it comes to-
I believe you might be right. It's very difficult sometimes to measure this. It's very difficult for the musicians to somehow get into that state sometimes. I mean, because if you want to get some serious, delta gamma stuff happening, you've got to like really relax, What we do, it's funny though, how the human brain works, because with all the musicians we've worked with, even though this is almost just like a random noise generator, when they're playing, they say they feel a connection with the music that's being generated. I think they're making it up. I'm not going to disabuse them of that. I go, yes, you probably are. And there probably is some. I mean, it is their brain waves. It is their brain stuff that's happening. So it's an intriguing thing. Actually, let's use that to segue to Nicola, because he's going to show you other kind of bodily measurement stuff and how we can go from there. So.
One thing I still wanted to say was that I was pretty fascinated. I mean, you have this random function in your patch also.
Oh, this guy.
Just a
Yeah.
drummed object, and it's remarkable how similar that.
Yeah.
Actually, I think it's smarter than I am. Okay, yeah, that's just a test. When I didn't want to hook up all the brainwaves and everything like that, I put in like this just drunk random thing. Yeah.
And what about Garageband? Does that have any use?
Garageband is a small version of Logic. Yeah, basically. You probably notice the interface is very similar, and it has great instruments too, so you can use that. The trick is that each one of these instruments is set to a different MIDI channel. See channel 1, channel 2, channel 3. That's how I'm able to talk to them all differentially. And you have to set it up in what they call multi-record mode to do that. Okay, yeah. All right, so let's switch over to I'm going to stop my screen share now. Hey, anybody on the Zoom call? Did you guys have any questions? Everything cool? Yeah, kind of fun, Yeah, let me turn my poor brainwave.
It was kind of hard to hear some of the questions in class, but
Okay.
Were you connecting Macs to Logic directly, or that was a different?
That's using an internal bus that's on Macintoshes. It's actually, the buses are labeled from Max 1 and from Max 2 and things like that. I was just using from Max 1, and the MIDI channels were all embedded in that channel, okay? So inside the, did I shut it down already? No. So let me show you here. Okay, so down, I'm not sharing my screen anymore. Hang on then. Where do I go to share my screen? Where did you guys go?
I see.
There you go.
I see. So those little keyboards are the MIDI translators.
No, those little keyboards are basically just using it to set my bass pitch, okay? Let me show you. Okay, hold on, I'm gonna share my screen here. Share screen. There you go. Share screen. I gotta say share. All right. Okay, so you can see this. Okay, like the flutes. Okay.
Mm-hmm.
Down here, see where it says make note? That's where I'm actually generating the MIDI note. Okay. Based on
Okay.
all these parameters I've gotten. Here's the pitch parameter coming in. These are the signal coming in. And then this note out. Notice it says from max 1 and then 1. That means send it out on that from max 1 bus on MIDI channel 1. Then over here, can you guys still see that? Can you see the logic?
Yep. Yep.
Okay. So I've set this up so that how do I display it? Oh, there we go. Somewhere I set it up so that it's receiving from max 1, you know, somewhere in all these like insane like logic preferences. Yeah, see, from max 1, there it is. Yeah, it's all turned on. So they're receiving all this data, and I have them disambiguated, channel 1, channel 2, channel 3. Those are MIDI channels that you can assign. And that's what that trail number does here. For example, that was the flute. Like I said, if I go to the gamelan, it's sending it to MIDI channel 5. And over here, that would be channel 5 right there, okay? So that's, I'm just using logic to provide the software synthesizers, you know, rather than RTC mix.
Yeah.
Because it's got like much cooler ones. Okay. All right, but I need to turn this over to Nicola. Okay, so here is your
Yeah, the cable.
cable. Okay.
Audio.
Okay. Yeah, go ahead. Turn this up. It should be cool.
Was it a cat or a dog?
So, can you hear me over there?
Yeah.
on
Can you
Zoom?
guys hear me now?
Yeah.
Okay.
Okay.
Oh, sorry.
Okay, can you still hear me, or was that? Yeah. Okay. Cool.
And we can hear you guys, right? Somebody say something.
Can you say something? Anyone?
Can you hear me?
Okay. Cool. Great. And we're set. All right. So what I'm showing is basically so what I was interested in was the question: how can I have a possibility to just get like gyroscope and accelerometer data of my movement and integrate that with different things. I mean, it could really be anything. In this case, my aim was to like sort of build a fucked up drum machine, and sort of the solution that I came up with in order to find something that has a relative invisibility was just to use an Apple Watch because I had it anyways, and I thought like, wait a second, I mean, they must have this data. So I did a little research on like how I can use the Apple Watch in order to extract different data that it is transmitting and use this in Max MSP, Ableton, or whatsoever. So I'm just going to show you the app which I'm using, and then I will show you how this is imported into Max MSP and Ableton Live respectively. So let me show my screen share. So the app which I found that sort of is suiting this idea of using the watch in order to transfer the data directly into the computer in real time is called Holon IST. And luckily, they also have a Max for Live plugin. So you go to holon.ist, and there you find the app, which I'm using for the smartphone. I will show you how the app works on the smartphone in a sec. And you can go to holon.ist/Ableton in order to find the Max for Live object, which you can download for free.
Yeah, we'll put all these links in the class webpage.
Yeah, and so once you downloaded the Max for Live app, or the Max for Live object and the app, It sort of looks like, let me stop the screen share. It looks like, oh, now I'm gone. That is pretty good. Only, so now this looks good. Can you see this? Yeah, you can. Okay, wonderful. So this is when you open the app. I mean, actually, it offers connectivity for a bunch of different sensors, not only the Apple Watch, but the Apple Watch was the one that I was interested in. You can also connect it to a bunch of other sensors. When you open the app and you go here into presets, I think, here you can see, you can even use the data of like Airpods. Apparently they have XY also. Apple Watch, both are MoveSense. There's a bunch of different things you can just connect. So I mean, I would also be sort of interested in what it is with the AirPods, but the idea of being on stage and having AirPods in the ear seemed like weirdly autistic, so I didn't really pursue that. But it's totally possible.
Are there sensors in AirPods?
Yeah.
I didn't know that.
Well, I mean, it makes sense if you think about the possibility of having like 3D audio. I mean, they must have.
Yeah.
But I sort of also didn't really think about it much.
Yeah,
So
they have 3D audio, it's horrible.
yeah.
But you can track them on my iPhone.
Yeah.
My friend that works for Apple, he's retired now, but he's trying to convince me that it was really cool, and he couldn't. He's retired, he says,
yeah, and then you can link it via, you can use OSC, MIDI, or Pure Data link. In this case, I'm going with OSC data that are being sent. And here you can see all the data that is coming from my Apple Watch via Bluetooth to the iPhone right now. And when I raise my hand, you can see this is happening. And there's a bunch of different things that you can use. There's also a bunch of different things where you ask yourself, how does it do this? Like temperature, cloud, humidity, wind speed. I don't know if it gets that from somewhere else, honestly, I don't think. Moon elevation.
We're gonna, actually, that's the last demo I'm gonna do today, is to show you how to get those.
But really the part that I'm interested in here is basically measuring the movement of my hand, like up, down, and sideways. You have the also the heartbeat rate here. Clock LFO is the heartbeat, and
Your clock?
yeah. And you can basically assign. No, don't worry. I mean,
Sir, but
so-
why the clock LFO isn't doing anything?
Yeah. Because I'm dead.
You know, those Germans are pretty cool.
Yeah, let me maybe show you one way you can see more happening. And here you can see as I move my hand, the data is coming in. And here now I'm deciding to send it as OSC, and I can decide on a bus and a channel that this is sent on, which is actually quite handy to be able to manage a lot of different inputs at the same time. It also has a bunch of other things which are interesting, like for example this one here. I will show you later what's happening with that.
So
It just changes basically the address that the data stream is sent on. I will show you. And the nice thing here is that there's, for example, some like categories where, for example, it would be measuring my arm from here to there, and another one goes from here all the way down. And that's sort of interesting if you think about mapping and sort of getting a somewhat mapping that is more complex and sort of achieves a different form of control. And I think with a lot of these things, really what at least I'm interested in is getting a control about data and about sound in the end that is somewhat embodied in a different way.
You know, what I get a kick out of is reading down gyro Z, gyro Y, clock, arm up, sun is up.
Oh, yeah. this one here is also good. It measures the speed of movement. That's also good. You see here gyro.
Yeah.
So it basically, the faster I move, the further it goes up. Yeah.
Wow.
Okay. So this is this end of what we're doing.
Yeah, you guys on Zoom, and unfortunately this will be the case with the recording. You can't see what Nicola's doing, but he's like literally just moving his hands around.
Ah, yeah, right. I'm sorry. My camera is, of course, the. I'm sorry. I forgot. You are not seeing a little image of me. Let me do this differently. Then it works.
Why did you put it on Twitch?
I can. No.
Okay. We have the data.
Okay, that's a very analog. That's very analog solution. That's very good. That's very good. Okay, so here is me. No, here, and you see the here. You see roll. Oh, not doing anything anymore right now. Hello.
Oh, we broke it.
Yeah. And let's try this again. Hello. Is this leaving me in the middle of it? 1 second. Now we're back.
There you go.
You can see it also measures, which is kind of nice,
Bizarrely,
the roll of the
it's,
hand.
It's flipped. I know Zoom does that sometimes. Yeah.
Yeah, I'm sorry for the, I
That's
don't know
okay.
why it does that.
I don't either. It does that to me sometimes.
Yeah,
You know, like my hands are like weird.
but you know what we can do is this, and then I actually do screen share, and I show you my OBS, because now you should be seeing me and OBS at the same time, so that's maybe better. Okay, once again, so could you follow the different categories that I was showing, or was it all inverse for you the whole time on
No,
Zoom?
it was only that last time.
Okay. So yeah, here you see, and then I do movements, the data comes in. Okay, so far, and now let's look at what we can do with this. For this, okay, let me stop my screen share. And I should say that what I'm doing usually is to connect not via Wi-Fi, but really with a cable into the computer, just for the stability of the connection, because I made so many experiences with Wi-Fi on stages that is medium reliable. So usually, I mean, Bluetooth seems to always be fine, but Wi-Fi is.
I've had problems with Bluetooth too.
Oh yeah? Oh, okay. Well, never mind all these wireless connections. So I mean, you can use this in Max MSP the same way you can use it in Ableton Live via Max for Live. The reason I'm using Ableton here is that I really like their the drum machines they offer.
You need to share your screen now.
Yeah, it's coming. Okay, so here you can see this is the Max for Live object, which is provided by Holon IST. I will open Max and we can have a look into it. 1 sec. Yeah.
Oh, Lord.
Here you can see this is just the definition of the port, and here's the UDP 7000. So this is in this case the channel that this is sent on. So the data comes in UDP, and then it's being routed, and this is where the bus and the number that I showed you earlier become interesting, because you can change the bus. Or you can also just multiply it and have all buses run at the same time. It's really, it doesn't matter. This is really for convenience to be able to switch around the different buses. When I'm using this myself for other things, I just go straight with the addresses that I want. Yeah, this is sort of the layout. And here, as you will see, the idea is that you can map this data to any parameter that you're using in Ableton. Of course, if you work Within Max for Life, within Max only, you can forget about the mapping. You just get the data coming out from here, and you can scale it to wherever you like. I don't know. I've been also building some projects where I'm basically just controlling effects for like incoming audio signal with this, and then of course I'm not relying on this mapping
Is it
function.
pretty much like a terming?
I don't know. I mean, let me show you something which is a little bit like terming, and then I will show you something that isn't.
Probably depends on how you're using it.
Yeah.
You could do that.
Let's see. Now this is gone. Okay, I need to restart Ableton. 1 sec.
Is this using the same technology as those gloves?
Gloves.
Which gloves?
What's their name? Like,
Oh, the Moo gloves or whatever they're called.
Yeah, image and heat. And who else has the gloves? It's probably, those are probably precursors to this. I think that this is probably much more advanced. You know, I mean, to fit a sensor it's doing all that inside the iWatch.
Yeah.
You know, that takes a company like Apple to.
Yeah.
And I think it's really, I mean, not that I want to do Apple advertisement here, but 18 hours of battery life is quite an argument for that, because this is quite long in terms of like, you know, counting on this thing working on stage. That I sort of like the idea of having 18 hours of battery life.
Long performances.
Yeah.
Yeah.
Okay,
I
so
think those kind of paved the way. I mean, you know, you can still use some of that stuff, you know, with the force sensing resistors and stuff like that with Arduinos. You know, but these are like really high end.
and the other thing, as I said before, which I like about this is that it's somewhat invisible on stage. It doesn't look like a sensor. And there's something in terms of performance that I find quite interesting, that it's not really telling the audience.
It's like magic.
No, I don't know, but it's interesting if there's things that you don't necessarily understand immediately. And there's a lot of other things which I immediately tell you that it is a sensor. Like, for example, if you would be using, let's say, Wii controllers, this is so common that as soon as you see the Wii controllers on stage, everyone knows what's going on. And yeah. Well. Okay. Anyways, so here I prepared something that is a little bit like a theremin, you could say. So I mapped the just the incoming lifting of my arm and turning around of the hand to one sawtooth and a square wave.
Hey, before you play it, are you going out to Zoom?
I think I am, yes. Tell me if you hear it, but I wonder why I'm not hearing it. I know what it is. Okay. Yes.
See, I think you have to go to Zoom.
Yeah, but what I did was to patch it around that with loopback.
Oh, I see.
Yeah, I know why. Okay. One last time. Can you on Zoom say something again?
Yep.
Hello.
Okay, so this is still there.
Thanks, Ben.
That's really interesting. One. This should be going out.
It looks cool.
Yeah, no, it's. I mean, we should be hearing it.
Try going to Zoom.
Let's just take a look at loopback. It is there, but do you hear this on Zoom? Do you hear some like squeaky noises?
Oh, I can hear the audio really well, but I can't hear you over it.
Aha. Okay, then, one sec. Now you can. Can you hear me on Zoom? Oh, okay, cool. I'm sorry. So now we should be able to do this without feedback. So let's try again. Yeah, very good. Okay, sorry. Okay.
Wow.
It's these two here at the bottom. See how I can keep one of them on the bottom? So this is the lifting of my arm and this is the tilt. I mean, if you practice this for a little bit, I think you can get quite good at it.
Why is there like one octave of two sounds?
So the trick here is that I'm mapping the lifting of the arm to one. That is the saw on the left, I think. No, that's the square on the right. And the saw on the left, this is here, is mapped to tilting the hand.
Okay.
So you have two different axes which you are using in order to control the sound, and that's sort of where the flexibility comes in.
Can you control the precision of how you get the signals? Like if it's changing really fast, but you wanted to like make it not that sensitive?
Yeah, you can totally. I mean, that's just a line object.
Okay.
Then you would. It's a max object. You would just need to put a line object in between, and then you give it some like time so that values don't change immediately, but they slide from one point to the next. Then you can make it smoother. Absolutely.
Okay.
Okay, so how much time do you still need at the end of this?
I probably need about 20, 30 minutes.
Okay, then I should, then I will do the quick version and not really explain much about how a drum machine works in Ableton and just go straight to...
I think just do that, yeah. Because I can do that.
Okay, so here I made a larger version of this. As I said, it's just like copy paste, but so that I have some choices here to use bus B and at the same time bus A, and again bus A or whatever I want, and then I can assign the different values on the app, because really it's not fixed which value is sent on which bus and on which channel. That's open. And then what you do, it's sort of a standard Maxwell Ableton function, is you click on map, and then you can, for example, let's say map this value. So I click here on map, and then the next value I click on will be controlled by the input of this map. So like, let's say, for example, I take the grain of the fuzz, and now you look at this value, and I move my hand, and this value is changing.
Oh, yeah.
So that's the idea here. I can map the input that is defined in the app to any value of the setup that I'm working with. In this case here, what I'm interested in is to be able to control the sounds of the drum machine and some like effect parameters that I put behind here. I'm sorry, this is all, I mean, to explain how these things come together, I think maybe we don't have enough time. But generally the idea is that the sound comes in this case from here, and goes all the way from the left to the right. And so by dragging and dropping different effects in here, you have basically a sequential chain that goes from left to right, the signal passing through these effects. And now the idea is I can control the drum machine and also the effects by moving my hand around in the air. So let's try this. What I brought for this, I mean, that's just because as a guitar player I'm so used playing with my feet, is this. It's like a foot controller. So I wanted to be able to play the drum machine with my feet, because usually with my hands I would be doing other stuff. So the idea was, okay, let's build a drum machine that I can actually play with my feet. So, yeah, very good. Like about this is that it's impossible to be constant. It's always changing. Even if you try to be really stiff, it's always changing, and that's sort of an interesting thing about this, because at that point it becomes like very gestural. Okay, let's do something that's maybe fun. Where do I have this parameter? I think it's, give me 1 sec, because what I want to show you is like mapping my heartbeat to the drum machine. That's sort of a fun thing to do.
So you're going to come alive now, huh?
Yeah. So this is on A8. This is currently mapped somewhere else. Now let's do. So right now what I did was turning this, you see, changes the speed. This one here changes, you can see it's here, it's called distance in this arpeggiator that I'm using here. And I can also, for example, pitch this up. I have a bunch of other sounds here. But let's go down again, okay. Okay, so now, I mean, if this was, you have to think this is MIDI notes. So basically, if I'm playing this here, I'm sending a C, and now it plays C, 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 and if I go up, now it plays C, E flat, C, E flat, but on E flat it's a different drum sound. And this way you're able to move up the drum scale. Okay, so now let's map my heart rate to the speed. Let's see how it changes pitch. Oh, that's maybe. You see, it's changing very, like, a little bit. Okay, so this is one of the things you can do, and
Are we controlling the pitch?
Well, the heartbeat, of course, is always changing a little bit, and this changes the pitch, because this is now going so fast that you hear a pitch, because the repetition is so fast. It could also be very slow. You can change the values, and then it's sort of slow. But of course, I mean, I think it's quite interesting that when it's so quick, you really hear the changes in pitch. I mean, you could totally be doing like a minimalist performance like this, and you just sit there, and have the pitch go on, it just changes all the time as your heartbeat changes a little bit.
I'm curious, were you a percussionist?
No, I'm a guitar player.
Because I wonder, for traditional percussionists, the gesture and motion is so central to performance that you have to sweat to perform.
Yeah.
In this case, it seems like the most effort is used in keeping still and making the most micro changes you can. I feel like it's a very different experience if you're a percussionist.
Yeah. Well, I mean, you could, of course, also be doing it similarly. And I mean, there's certainly been a lot of projects using like gyroscopes where basically you play drums in the air and you get the drum sounds because it also knows your position. It's a possibility. I don't know. This came out of honestly me playing synthesizer with my hands, and I thought, like, how do I get the drum machine in here that it becomes like really unstable? So I did something where I felt like even if I do this, it makes a huge difference to this, and I can sort of swap out the control of this and still be functioning with playing the synthesizer and play a drum machine at the same time, because I have so much control over the movement, and then it's still functional to that synthesizer. But it could really be anything.
Actually, what you're talking about, they actually had a product that was available in the late 80s, I think, called air drums. And they're just sticks with sensors in them, and you just play them in the air like that. Yeah, they didn't work very well.
Okay, let's just do like one last thing for fun, and then I think we have to go on. So this is now just mapping two different reverbs to the movement and as well the speed. So check this out. There's a different reverb. So up is a reverse reverb, and down is a different reverb. And that's sort of interesting if you think about the sort of quite like non-linear control you have about these. If also the speed of the drum machine is with it. But I don't know. I mean, I feel like I can totally get comfortable playing like this. You know, because it's after some time you get to know how it works. So this is a reverse reverb that you're hearing, and here's the one here on the right. So it's between these two. It's just like going changes now basically dry wet value. Well, okay. Yeah, that's sort of it. Yeah.
Yeah. You guys on Zoom, could you hear what he was saying much at all? Good. Okay. Because I wasn't sure. I want to make sure that comes across. My suggestion is people who'd like to do things with the iWatch or something, just write Nicole and
Yeah, just reach out.
You know, because he can show you how to set it up, and you know, a lot of the stuff is already made, like for Ableton and Mac MSP and stuff. So you can do some pretty cool things with it. Yeah, amazing.
Yeah. Any questions about this?
Okay.
Alrighty,
Okay.
we're going to switch over to me again for one last thing. Here we go.
Where did I put my adapter?
Oh, yeah. Sorry.
Because my computer's old. Okay, hang on.
Can you guys hear me on Zoom? Okay, cool. All right, so the last thing we're going to do is what's that?
Margaret's dog.
Where's the dog? Oh,
Please don't.
my favorite.
This is Stanley.
I like it. Seth has this dog, and at some point, like the dog's snout will always come in like this. You know? It's pretty amazing. Okay, so we're going to do one final thing, and this is also looking at a live data stream. Only this time, the live data stream is going to be a weather station out on Whidbey Island, where my West Coast place is with my wife and everything. Okay, and I want to talk about, you know, like the data sets that we looked at last time, part of the biggest part of this game isn't necessarily even the audio coding or anything like that, but just figuring out how to use it, okay? And I want to kind of walk you through some things, and I'm just going to show you a very simple kind of thing that I did. Okay, so let me share my screen here, okay? And sound is on, it's at stereo, yes, okay? So there, you guys can see the screen, right? Okay. All right, let me go here, okay? And the trick is you've got to find like websites that, and each website is going to have a different API, they call it, or application programmer interface. And the one that I found that seems to be really good is HTTPS. I think I can just type in openweather.org. Yes. Okay. And this one is really nice because it's free. I mean, you can also kind of get a version, but this is very popular for doing. And the thing you want to go to is API, okay? And that brings you all these different things. You can get these different APIs and everything. We're going to look at the current weather data, okay? Now, at some point, if you're going to use this, you have to hit subscribe, and it's free. You can just say, do this, and you're going to get this thing called an API key. And that's what you're going to use to actually request the data with. Now, I'm going to show you my patches, and I hopefully have set them up so the API key does not appear on the screen, because there are nefarious people. Probably Vladimir Putin is looking to get this API key from you, and then he will like run this up to the point where you're going to have to start paying money. So I'll be careful about that. But let's go back to the API. And what we're going to look at is the API doc, okay? And what you're going to do is you're going to create an API call, okay? And this part of it is always that, okay? The next part after the question mark is where you say things that you want it to know, like the latitude and longitude. Now, you can also specify this in terms of city name or zip code or anything like that, okay? And basically, this will tell you, what you'll do is you'll say like zip equals, and then you give it the zip code, okay? And then the final thing you give it is that API key, that and ampersand app ID, okay? So like I said, that's gonna be off the screen for you here. Units, this is kind of important because it will start with standard units, and like you're gonna see the temperature in degrees Kelvin, which doesn't do you a lot of good, okay? Unless you're like a physics geek. You know, so I generally set my units to be imperial, which is imperial. You know, that's going to be inches, feet, you know, Fahrenheit, things like that. Okay, and here's an example, okay? So this is going to give you the weather from latitude 35 degrees, longitude 139, and then you give it the key, okay? So this is what comes back, okay? And you're not going to see this. What you're going to do is you're going to say, I want main temperature, or I want wind speed, okay? But you kind of decode this by saying, well, there's this thing, and then there's these sub things underneath it, okay? So I think, yeah, that's pretty much all you need to understand to kind of get this to go. And let me bring up a patch and show you kind of how it works then, okay?
You make these calls directly to Max?
Yes.
Oh, wow. Okay,
Yes,
cool.
yes, yeah. I'll show you. I'll show you.
Do you know what the clouds is actually mapping?
It's basically the percentage cloud. You know, actually, that's one of the challenges is trying to figure out what some of these things do. Okay, that's why we're going to look at something simple like wind speed, okay? Because I know what that is.
So you don't have to use all of them.
No. You actually, you make requests. Once you make the API call to the location you want, then you can make requests because you're going to get all of this back. And then you tell it what you want to print out, okay? So actually, let's take a look at that, how we do it. Okay, so let's go here. Let's go to data sonification, week 7 safety. Okay, and the first one I want to look at is, wait, which one do I want? Oh, yeah, and then we'll do the music later, okay? The first one I want to look at is stream data 1, I think, okay? So let me open this guy up. Okay. Yeah. Come on, Max. You can start. There we go. All right. Yeah, see, I've got the and app ID like off the screen there, okay? So basically, I created this JavaScript object that what you do, notice that this is that kind of thing. Hold on, I'm losing my brain. Remember I said that this part is always the same? Well, what you're seeing here is basically, it's an HTTPS call, okay? You can actually copy and paste this in your browser, and if you go to that, you will get then all this stuff back down here, and you'll see it in your browser, okay? But we don't want to see it in a browser, we want to see it in Max MSP so we can do cool stuff with it, okay? And I think I just, oh no! Okay, so what I've got here, we're going to quit Max 8 as soon as it starts up, okay, is that I have a couple of these API calls constructed. Now notice that what I'm doing, is this the right one? Which one? Yeah, about Max. That's the Max 8, okay, so I'm going to quit that one. Sorry guys, okay. What I do is set stream allows me to send over that query. And I'm going to ask Seattle, give me your information. So I go boom, okay? And now I say load JSON. That will then give me all that data from that website. And then I can say get data wind.speed or main.temp. That's how you decode this thing. Main, notice that there's little brackets, .temp. Wind, and then there's brackets, .speed, okay? So if I go over here, to my Mach 7 again, now I say get data wind.speed, this will tell me that currently it's giving me the wind speed of 3.09 miles per hour. I can get the temperature, and notice that that one is in Kelvin, okay? Because 282 would be a little warm out there right now. So what I did on the second one is I say clear equals saddle, and the units are going to be equal to imperial units, okay? So now I click that guy, I load the JSON, and then I say get main.temp. Yeah, that's more like it. It's 47 degrees, 0.97, all right? So this is all there is to it. And notice, we're getting the values out here. Well, duh, we know how to use those to create sound, right? All right. And let me take a little bit. Yeah.
Basic question. So when you load the JSON file, how does it know it's loading from the website?
Because you click that first, okay? So I say I wanted to do this thing, click, then load JSON will go there, okay? So it's just and then you get the wind.speed there, okay? I go click, load JSON, get the temperature, okay? And down here, this is actually my zip code, okay? So I can actually be very specific. Click, load JSON, get the temperature. Ooh, it's a little colder there than it was in Seattle, okay? Because we're up on the cliff. Okay, so this actually is working. It's kind of intriguing. Now, so I thought, well, I want to sonify the wind speed. You guys don't realize, but it's really, really windy on this island, and we're on the very southern tip, like right out on Puget Sound, and the wind just comes up and it's like pretty fierce sometimes. That's one of the things that the real estate agent did tell us when we bought the place, but it's kind of fun, so we like it. I want to sonify that, all right? So let me close this guy off, and I'll show you what I came up with for sonification. Let's go here.
Is set stream something special? Because my Macs didn't name that.
No. Those are ones that I made.
Those are ones you made?
Yeah, that's
okay.
I wrote the JavaScript object. You'll have to have that, because those are actually commands into the JavaScript object. Okay, yeah, right. That's not a Max thing, anything like this. Okay, I'm using this instrument called IIR. Okay, and IIR is called Infinite Impulse Response Filter. Okay, and it's one of my favorite instruments in the whole RTC mix thing. Okay, and it works. It's a very old instrument. This was written back in the 1980s. So you basically have two different things that you have to do to make it work. One is you say setup, and you give it a center frequency, a bandwidth, and an amplitude. And you can actually have a whole bunch of those different center frequencies, bandwidths, and amplitudes if you want. But I'm using just one because I just want one band of noise, all right? And I'm going to use MIDI note values, and I'm going to add this to it. So I'm going to get a nice little chord out if I want, okay? And then I set up the amplitude, the bandwidth. Let's start with a bandwidth of 100 first of all, okay? And yeah, let's now see what this sounds like. This basically will take my input and it will map it between 0 and 20 to 48 and 72. Actually, this is not the one I wanted to show you guys. Hold on a minute. Oh, I don't know what I did with the other one. Okay, we're going to have to go with this one. Okay, this is the one that's being set up for the wind speed because I just figure, well, I don't have to know the bounds. The wind speed is going to be between 0 and 20 miles per hour. Okay, a lot of times it gets above 20 miles per hour, but what the heck? It's not going to do that tonight. Okay, and then I just randomly choose this much to add to that base MIDI note. And the MIDI note is going to be between the C below middle C and the C above middle C. And then it's going to set it up, schedule the note, and make it kind of go. And it sounds, with a bandwidth of 100, okay, let's make, damn it. Let's give it a MIDI note, let's give it a wind speed of like 9 miles per hour, okay? So I hit this. Can you guys hear that on Zoom? So it sounds windy. You can hear there's a little pitchiness to it, right? So I thought that was kind of fun. But I'm like a real pitchy kind of guy. So I'm going to make the bandwidth be only 1, okay? And you'll hear this. So it has a windiness to it, but it's also got a pitch to it.
Brad, what's causing the variations?
Okay, well, I was about to explain that, okay? What it's doing is it's randomly choosing this much to add to the base MIDI note value, okay? So I get the base MIDI note value here. It's going to be between 48 and 72, depending on my wind speed, between 0 and 20, okay? And then I'm going to add a certain amount to that. Well, why am I doing that? Well, there's a problem that I discovered when I was working up this demo for class. The wind speed doesn't change very often. I don't know what the sampling time is for this particular weather station, but if I was going to have it play just one note, and then as the wind speed changed, it would like move the note around. Well, I set it up and I listened to it and it just went. After about 3 minutes, I said, this is not going to be really compelling to listen to. So I tried to imagine, well, how can I make this more musically interesting? And what it does is it will kind of like create these sort of subtle arpeggiated chord things. But then as the bass note changes from the wind speed, it'll shift them all up or down by different amounts, okay? So it gives you something kind of pleasant to listen to while you're waiting for the wind speed to change, all right? Let me show you what the final version looks like then, okay? Does that answer your question, Ben? Okay.
Yep.
Let me start this guy up. Okay. And there's my zip code. Okay. So let me send that in. Okay. Let me then start the metronome. It's going to load the JSON. It's going to get the wind speed. And let me start up the sound. Now, what this does is this deliberately waits. This will wait 30 seconds before resetting that, reloading it, and getting the new wind speed, okay? Notice the wind speed is now 3.44, so it changed a little bit from when we were looking at it earlier, okay? Tell you what, let me make this happen every, say, 10 seconds, okay? So I'll start this up, get this guy going again. There we go. Okay, so in about 10 seconds, you'll see the bang happen, and I guarantee you the wind speed won't change, okay? There it goes. It's still 3.44. So basically, I set this to like 30 seconds, thinking it's going to be a long lag, you know. And I think it was a Monday morning. I was doing work at the apartment, and so I just turned this on and let it run. And it was actually really cool because it really didn't change very much, but it did, you know. And so it created this very, very ultra minimal piece where it's generating these kind of nice ambient tones in the background. But gradually they would shift over time. And at some point you go, whoa, that shifted over time, you know? So yeah, unless there's, you know, some huge wind event happening somewhere, hopefully not at our house, you know, you're going to get kind of fairly static numbers, you know? And that's actually another challenge when you start thinking about data sonification and things like this. Somebody was talking about how weird it was. I was telling them about this class. That, you know, whenever they have like a new discovery, like out in the NASA discovers something, you know, it's like, and then they go, and here's the sound of Jupiter's atmosphere, you know, and it always sounds like little chimey wind chime things and everything like this. That's not the sound at all, you know. First of all, because it's changing in time that we recognize, and generally, astrophysical stuff doesn't do that, you know. It either like goes for several billion years, or it happens in like several petananoseconds, you know, like it bangs, you know. So yeah, it's always a trade-off, you know. How much are you going to like spend thinking about the artistic impact of this, you know, and how it sounds, versus how much do you really want to like sonify the data and really listen to what it does. So this is my solution to the wind speed problem, but again, you can look at a lot of different data from different places. My wife had a really interesting idea that we haven't done. She said it might be fun to compare two different stations. And you could actually set it up so that when they're in sync in some undefined way, they would create a consonant chord. And you could hear as one maybe drifted out from another one. Like maybe you could look at the temperature data from the Pacific Ocean, one at the entrance to Puget Sound and one a little bit further out. And you can see how they might kind of like play off each other, depending on how consonant the chord was. Yeah, I didn't have time to do that possible project for people, But the thing that was amazing to me was how simple this was to actually get the data once you figured out, It's like I said, all you do is look here and you figure out what fields you want to do it. And there's a whole bunch more fields down here, as you scroll through this. There's the wind on speed, clouds, rain, all this stuff that you can do. This is an example of how you do it in a web browser or something like this, So yeah, it's pretty powerful and it gives you a lot of stuff, okay? This one, the city ID, I think down here, on one of their pages, there's actually a whole downloadable list of city names. Oh, city names, that's what I want. Yeah, somewhere. Yeah, you can actually get the city list by downloading this file here. It's a giant archive, and you can actually just call it by city. Or I find using zip codes to be pretty easy. Or you can actually look on Google Maps and get the latitude and longitude of things. All right, well, hey, right on time. Thank you, Nicola, that was wonderful. Sorry we didn't have time to go through the whole drum machine with everybody, but yeah. Okay, any follow-up questions? Everybody cool? You guys okay on Zoom? I'm going to start my share here so we can see everybody. Hi, everybody. And Ben, next week you're on. Now okay. You're not going to be here in real life, are you, for next week?
Oh, unfortunately, I can't.
Yeah, you're out west or something, right? Or
no,
something.
I'm in Boston now. But
that's just as bad. Okay. Again, we're going to split it next time because we got a little bit of a jam up. We're going to do half of it with you and half of it with Ryan Carter. Okay.
Okay.
And Ryan will be talking about his RTC mix work. I know a lot of people are very interested in your extensive knowledge of cool data sets and fun places to go to get stuff like this. Okay.
Okay.
So,
yeah, there's a bunch of things I could do. I don't know. I have an hour.
Yes.
Yeah. All right.
Okay.
Yeah. I was thinking I could walk through part of it. I could walk through our paper in Computer Music Journal on the geyser. The geyser.
Yeah, because that's a pretty cool example too. Of actually using the sonification to kind of inform the science too.
Yeah.
Great.
And then some stuff on earthquakes, and then some stuff that I'm working on now.
Great.
Yeah.
Okay, I'm going to shut off the recording. Bye, everybody.
Bye, everybody. Thanks.